Hi, Assalamualaikum. My name is Tengku Nazrin. So now I will present about the process description and schematic diagram. So now I will present about the PNNIT. The loop above controls the temperature of the process of fluid by flowing the fluid and water of the cooling medium into the heat through the exchanger tube as the water passes through the shell. Exchanger process fluid pass. In PNID, TW is a field mount temperature sensor located inside a thermal well. The signal from the sensor is transmitted through a temperature transmitter installed in the TT101 field to a temperature indicator and TIC101 controller located in the control room by an electrical signal indicated by a dashed line. Based on the point set in TIC101, then sends an electrical signal to TY101 located on the farm or factory. TY101 is a 1 per P converted I to P. Current to pneumatic signal converter. This is because TY101 receives an electrical signal from TIC101 and then converts it into a pneumatic signal which then acts on the control valve shown in the PNID above. The control valve is then open or closed to increase or decrease the flow of water into the heater exchanger. The key to understand part and instrument PNID diagram is to become familiar with the ISA PEID symbol for the most process plant instrument and equipment, and then read as many pipe and instrument PNID diagram as can use. You will be amazed at how well you can read and interpret pipe and instrument PNID diagram. So, basic pipe instrument PNID diagram based on PEID symbol for the most process plant. Continuous steering tank reactor, Advance Buss Loop Reactor (ABLR) has a set material input and output. In ideal service, ALBR is well paired with no ditch areas or bypass. Confusion may or may not be included. The assumption for an optimal ABLR are that the tank has a constant scope, composition, and temperature inside, that the effluent has the same composition as the tank, and the tank is in any state. ALBR appearance bleeding tanks have historically been used. This is not always the case. The previously stated assumption can be met even in long tube if the mixing characteristics in the reactor indicate a strong dispersion. This is still so with a gaseous liquid where the column bubble mix with the liquid.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rishami, and today I would like to explain a little bit about the description of the Advance Reactor. So basically, the Advance Reactor that we choose is ABLR, which is Advance Buss Loop Reactor. Alright, so we go to the description, which is it have a reaction mixer, reaction vessel, the external heat exchanger, and lastly is the circulation pump. Alright, so each one, the reaction mixer function for the high performance gassing tool. It's to stabilize the pump liquid flow through a nozzle that have a high velocity jet. That's for the external heat exchanger. It can go large as required and it's not limited by the reactor working volume. And lastly, for the circulation pump, it can allow a high power input for working volume in those cases with high mass transfer. Right, so let's see for the operation of Advance Buss Loop Reactor. Right, in ABLR reactor is the change of the neutral mixture that to the comparing amines. The item is constantly sieved through the cross stream sieve framework and through the reactor framework. Right, so because of the great exothermic response blended vessel, it would require the utilization of the dissolvable to weaken the arrangements and to decrease the warm delay. So as conclusion, this model or ABLR shows that when we utilize a mixed autoclave the absolute volume would be in any event a factor 5 to 6 higher than when utilize the bus innovation. So that's all from me. Thank you so much. I hope you will understand about the advanced reactor. Thank you so much. Assalamualaikum.
Assalamualaikum, my name is Muhammad Daniel Hafi, and today I'll be explaining about the component and in reactor and its function. So first we have heat exchanger. Heat exchanger is a device that used to transfer thermal energy between two or more fluids between a solid surface and a fluid. Next we have circulation pump. It is a specific type of pump used to circulate gases, liquid or slurries in a closed circuits. Circulating water commonly found in heating or cooling system. And next we have shell exchanger. The shell and tube heat exchanger is used to transfer energy from one stream to another. Next we have thermowell. Thermowell protects the instrument from the pressure, flow induced forces and chemical effect of the process fluids. Up next we have the transfer transmitter. The sensor measures the temperature while the transmitter amplifies and transmits the signal to the monitoring system or control room. Next is control valve. It is to open or close to increase or decrease the flow of water into the heater exchanger and manipulate a flowing fluid such as gas, steam, water or chemical compounds. And finally we have autoclave, a strong heated container used from chemical reaction and other process using high pressure and temperature. So that's all for me. Thank you.
Hi, my name is Muhammad Aiman Robat, and now I'll be talking about advantages and disadvantages of this reactor, ABLR reactor. Okay, the first part will go to advantages. The first one is highest mass transfer rate and unconstrained heat transfer area proven in industrial plants. Second, significant saving in catalyst cost. Third, no scale-up problems on an industrial scale and guarantee process and performance. Fourth, reduction of reaction pressure, which is superior mass transfer rate. This consequently allows reduction of the initial investment cost of the reaction section and gas supply system. And the last advantage is excellent cleaning features. This reactor also has its disadvantages, which is higher capital and higher operational cost, which is more energy. In this case, 5 kilowatt over m cube is used to disperse the hydrogen in the liquid than in the traditional stirred vessel, where the energy requirement is typically between 2 to 3 kilowatt over meter cube.